So I'm going to talk for, well, 90 minutes. I am afraid it's a little bit too long, about how we did the open-close software at JFrog for the Artifactory server. So first of all, how many of you are writing open source software and open source product that you distribute? Okay. So the main thing that happened at JFrog for this environment and for the freemium Spring environment, is that we started in 2006 with the free open source application, and then we decided to go for a freemium. So I'm going to go over the history of this application and how we ended up creating the architecture that we did. And we thought that it was a nice story, and it's, I mean, as the chief architect of JFrog, I think it's a beautiful architecture, of course. But I think there is a lot of history around it since 2009, and it proved to work really, really well. So the OSS is the base of the architecture, and I'm going to show what is this architecture. We created some extension to the Spring environment, which today are kind of obsolete with the new 4.0 and 3.2 and things like that, like reloadable beans. But I'm going to show how we did that, and how we added the commercial add-on on top of the open source product, and all the layers and more layers on top of the application. And the last part, which for me is the most important part, is how we make all those different layers of the same application testable. And how did we create the test, and how do we make sure that everything works correctly in all these different environments and these different layers. Okay, so I'm Fred Simon. I'm the chief architect and co-founder of JFrog. And all my slides are created by Barrow, and so he likes to make fun of me when he's creating the slides. One of the main things about my career is that in '98, I founded with some friend Alpha CSP, which is a service company. And so I was a consultant, a Java consultant, from '98 until 2008, the creation of JFrog. And one of the main goals of a consultant, like you know, is to go to company to tell them how they should develop the software and make sure to leave before they actually do it. So during this time, basically, I observe most of the suffering that the developers are doing in their development environment. And this is one of the main reasons why we created JFrog, and why we aggregated all the frogs, is to solve developer pain, and this is what we are doing. We are creating developer tools and developer environment. So this is the frogs. We have two products, Bintray, which was launched last year, which is a public web platform for distributing binaries, and Artifactory, which is the one I'm talking about here, which is the binary repository manager for your local environment and your local build servers. So why do we think that Artifactory is the best repository manager out there? Well, who said that? The main reason and why we are here is basically everybody here, Spring, Grails, Groovy, Gradle, even the Scala guys and Jenkins, they are all using Artifactory and Artifactory Online to publish all their builds. There is no Spring releases that doesn't go through Artifactory to manage the release process and the deployment to all their users. Okay, so you can see here on the Spring repository, 500,000 artifacts, which are all the artifacts that they are using and all the artifacts that they are producing for all their different frameworks and platforms. Okay, so basically that's why we are here, is because the Spring community and the Spring ecosystem is highly using Artifactory, and we are really proud of the JFrog, and we are supporting all those guys on our cloud infrastructure, and it's serving a lot of millions of requests per day for all those guys, and we managed. I like to do just a small vote about basically who use a binary repository. Just for the history, we used to do that in 2008 when we started JFrog, and most of the people just were the last one, the caveman. And so I want to know how many of you are using a binary repository manager and how many are actually managing their binary software with a tool, and so not with a file system or with your version control system. So, okay, only 3? 4, okay, good, 5. Good. So we had a lot of great progress on this environment. And today, we are really happy that all the people are using Binary Repository Manager and are deploying their environment using good software and good tooling. That's the main reason why we created this product in 2006. This is at the beginning. We were just suffering, downloading from the internet all those jars again and again, and all our team getting different versions and having different behavior on each developer machines. And we said, okay, that we cannot work like that. We need a central place where we put all the jars and we know what people are using and make sure that we are distributing. This is what we did. Basically, it was the Maven time. Today we support Gradle and Ant-IV and NuGet and Ruby and a lot more clients, but that was the main itch that we wanted to solve, and this is what we solved. So in 2006, just before Christmas, we launched the version 1.0 of Artifactory. It was pure open source. It was just to solve our problem, and due to the large success and adoption of the open source product in 2008, with Yoav Landman, the founder of Artifactory, we founded JFrog Ltd. In 2008, and we created this company to try to monetize Artifactory and to see if we can create a company and a project around Artifactory. The story here, I don't know if it happened to some of you, is that when you develop an open source product, you develop at night, you spend some good quality time that you should be with your family, being in front of a computer and writing code. And as soon as you create a company and you are full-time job writing the code and writing software, the quality of what you're writing and the quality of the product increased by an order of magnitude. It was quite impressive how much basically embryonic Artifactory was in its version 1.0. And so in 2008, as soon as we put 100% of our time and 100% of our effort into the development of Artifactory, immediately the great improvements on the software. And we managed in 2009, end of 2009, to launch the cloud version, the SaaS version, and the professional version on top of the open source. Okay, so this is what I'm going to talk about, is how basically we started with a code base that was pure open source, just here developed on our free time to manage an itch. And we created a platform where we can have still the open source, and the open source is 20,000 installations out there of the open source version. We managed to create a freemium application on top of this open source software and monetized basically the open source. The actual story is that when we started JFrog, we said people can get the open source version for free. Why they will pay for something that they can get for free? And we said the natural choice is the SaaS. You provide with added feature like automatic backup, auto update, you manage their application. So there is this win-win situation on the cloud architecture and software as a service architecture, that the company that is creating the software is providing the full services. And so even if it's the same open source version, you are capable of monetizing the open source version by creating the SaaS environment. So we started with the SaaS environment, but very fast our customer and our users, they ask for an on-premise software to be deployed. And I mean, the cloud is quite successful, and we are really happy of our SaaS platform. It's used here for all the Spring stack, but basically the on-premise version of the software is still most of the revenue of the company and most of the revenue of JFrog. So 2009, the SaaS version, and right after the cloud version. And lately, one of the main success for me of the architecture is the Artifactory 3.0 that we launched at the beginning of the year, which was a full rewrite of the underlying storage engine of Artifactory. Okay? So for me to have a software where you are capable of changing the low-level backend and completely rewrite the low-level backend and make sure that you have full backward compatibility on the high-level API and the high-level interfaces of your product is quite a big success of the infrastructure. And I have to say it's mainly also due to the Spring and the Spring framework and the ability to do inversion of control and to have those services and those ability to test and stub every layer of our application. And so we managed to launch Artifactory 3.0, and we had more than a 10 times improvement on the performance of the system by completely tuning and rewriting the low-level backend system. So moving forward, what I want to talk about is how did we create this architecture of the open source version, on top of it the professional version, and on top of it the SaaS version, online version, and how do we create the test for all those different platforms, and how do we create a stable environment. One important thing also about JFrog is that whenever we create the professional or the open source version, so it's a downloadable zip, downloadable RPM that you can download for free on the internet for the open source, install it anywhere on your system. What you are actually getting, it's a piece of code that was already tested on the cloud version for many weeks. So we do continuous deployment on the cloud platform, more than once a week on the cloud platform of our code base. And from time to time, once we have a good list of features and a good version, we are creating the zip and the RPM and the distributable version, and we are providing it to our users and customers. So we are really, really confident when it goes out there. The application already run for quite some time on our cloud platform. We'll already get all the logs and all the feedback. And it took time, okay? It was not like that in 2009 as soon as we launched. It took time for us to work like that and to organize it like that. But it's quite a success, and I can see a lot of cloud provider and SaaS provider that have a hard time to set their development environment and the company culture and the company environment to work like that. And even more forward, in a couple of months, we're going to launch the high availability, fully cluster version of Artifactory, which is another box into the stack. It's actually between the Pro version and the Artifactory Online version. And so it's our ability now to add more and more layers to the environment. So stay tuned for Artifactory 3.1, which is going to be a full active cluster, high availability environment with one single database and multiple instances that will be able to connect to it. So the OSS version of Artifactory is really the ground and the ground foundation for our software. And they are really, I'm really not biased at all. They are very good foundations. But so what's really nice about being open source is that, of course, everybody can have a look at the code, and we get great feedback from the community, and we have a really nice environment about what's going on inside our code and inside the usage of the Artifactory foundation. This is the architecture in, 10,000 feet overview. And so Artifactory is just a WAR file. It's just a web application that works on any web servers. And it's using heavily Spring with Spring Security, Spring Transactions, and of course, Spring Framework and Spring Core and version of control. It's using Wicked for the UI. Okay, it was 2006 when we started. Please. But it's really good. We are really happy with Wicked, and they provide a good environment. We will not have choose Wicked today, but still it's a really good platform today. Jersey REST API. We don't use the Spring REST stack. It's the Jersey REST stack and our own WebDAV implementation for all the interaction. The main thing that Artifactory is doing, like I said at the beginning, is aggregating, caching, and distributing binaries. And so we are using any kind of JDBC accessible database for managing the metadata and managing all the folder names, file names, and security information. And we are managing a lot of HTTP connection to the outside world to actually aggregate those binaries that are coming from the outside. Okay? This is the architecture for the open source, for the professional, and for the SaaS version. The architecture doesn't change. It's basically just a set of features and different implementation at each different layers and for each environment. Of course, you don't care about nice-looking diagram. The only thing you care about is the code. So I don't know why I'm in sleeping mode here. I hope I have my power on. OK. One thing that is funny when you want to show actually the code and how we really did this work and how we get into it, the main thing about the code is that basically it contains all the features. Okay? Every time you look at one class inside your environment, you can see all the different architecture pieces. Usually they are bring together. It's really hard to take, okay, this is one class that is doing one piece of the architecture. It doesn't work like that. Everything is connected to everything. There is still the inversion of control. So the main thing that I want to basically to start with for the main architecture is that it's the web XML. This is where most of the people are getting in, and it's the same web XML for all the different versions. We use mainly filter. I don't know people that are using more and more servlet, but filter are really nice because it makes the chain immediately, and it's a lot easier to control and to add features and to have more flexibility about adding new extended feature for put request of professional version. We have, for example, also LDAP integration, which provide you the ability to do automatic login to your LDAP server and group servers. So it's an extended feature on the authentication mechanism. When you have a filter, it's a lot easier to have this flexibility using filter. So we have a filter for access, filter for request management, and request for repository management. We have the wicked filter, which is the main one for all the UI and all the WI environment. One main thing that we did here for the wicked filter is that we did a delayed wicked filter. The main thing that we wanted is that we wanted the Artifactory server to start as fast as possible and then to start to initialize and plug all the pieces asynchronously. Okay? So we created this asynchronous initialization by ourselves. The main big part that is actually controlling which version you are running and what's going on inside Artifactory is actually the listener, the web XML context listener. Okay? So those guys, the last one, which is the Artifactory context config listener, which is starting the Spring context, okay? He's the one that's going to put together all the pieces and decide what kind of config and what kind of configuration that should be loaded. The first one, which is the Artifactory home config listener, I tried to find some other environment. It's in all the architecture that I used to see, I didn't find this level of ability to configure an application. Here, basically, with one single parameter, if you respect a certain configuration and etc configuration with the good parameters, you can really have different behavior of the same application, and you can really use with moving one folder from one places to another. A lot of our customers and users are doing that because Artifactory is a proxy for binaries. Okay, so once you get distributed and you have multiple data center and multiple build agent and multiple build farm and worldwide QA environment, you start to need to distribute Artifactory in different places. And so with the Artifactory home config listener, we can really give you the ability to set up with a couple of configuration files your own specialized Artifactory environment, and it's easy to read and easy to configure home config listener. He's the one, of course, that will tell you what kind of licenses is installed for the Artifactory servers and what kind of system should be loaded. But it's basically just analyzing the folders and the files of the configuration and not doing much. Logback, I'm going to pass. And the Jersey configuration, which is ClassPass and mainly ClassPass configuration. Okay? So from this, what I wanted to go and look into this one, which is basically the Artifactory home config listener, which is initializing this Artifactory home based on a file or based on a servlet logger. Okay, so you have different ways of analyzing this home and this configuration. You can do it from your web XML. This is what we do in the cloud environment, basically. And a file-based, which is what I just talked about from the init parameter. Like I said, from this home environment, one main thing is that inside Artifactory, I'm going to show you why it's like that, there is no static member, okay? There is no singleton and no static member. One of the main reasons is that we go cloud and we go multi-tenant. So we deploy the same WAR, okay, on the same Tomcat multiple times. And everybody is well isolated by its context and by its environment, okay? This was quite a challenge because we had to go in all the third-party open source system that we are using and making sure that they are not doing this mistake of having singleton and the same piece and a static member. Okay. There is a full talk, by the way, on the web about it, about how we did this analysis and all the tips and tricks and which third-party library you should not use if you want to go multi-tenant and have the same WAR file deployed on the same Tomcat environment. You can see here also the version detail about the running and the original version. Okay, we have an automatic update. I'm going to show you a little bit also how we do that. And the main thing that I wanted to show you is here, the inheritable thread local, which enable us basically to know in any thread what is the Artifactory home that we are talking about. And in the about this thread local, what we saw in a lot of the library that we are using, they are using also thread local, and sometimes they are creating threads, so the inherited thread local is quite important. But a lot of libraries, they are not doing the last part of the thread local when you are binding to your thread local, is to remove the whatever they bind to the thread local. I don't know if you, to do the unbind to your thread local. It happened to us on the Lucene environment. I don't know if some of you use the Lucene indexer and Lucene analyzers. But a lot of third-party software that we were using are not cleaning their thread local after themselves. Okay? It's a really big problem for us because, first of all, it's true that thread local are kind of cleaned up by the garbage collector quite aggressively once on a concurrent mark sweep and all these kind of things. But still, when you are in a Tomcat thread container, they have the thread pooling, and the thread local still stuck to the thread pool and to this for quite some time. So when there is a new request coming in, there can be some leftover inside your thread local store. And it's a really, really bad practice, and it uses a lot more memory than it should. Okay, the garbage collector works a lot better if you clean up after yourself, and if you unbind whenever you do a try, bind, finally unbind. It's not that hard, and I really, really hope that more and more open source projects will do that. We had to actually modify a lot of our third-party open source to actually clean after themselves and provide this kind of bind-unbind removal. I'm going to go back. Okay. So that was just a small overview of the basic open source. First of all, we started with the beans and with Spring Beans and with IOC right from the beginning. Okay, Artifactory was created with Spring and version of control right from the beginning. And what happened, so it was 2006, okay, so more than 6 years ago, 7 years ago. And what happened is that we had an issue of reloadable bin. Okay, in 2006, it was Spring 2 at the time, even, I don't even remember. We are running on Spring 3.2 today. And so there was no way to actually reload and recreate some of the bins and some of the Artifactory context and the application context of Spring. And so we needed to create a reloadable bin. And we don't like XML. Okay, we have a couple of, well, the web XML we needed. But most of our Spring configuration is based on the annotation, and we annotate our bin. And so we like to have dynamic, reloadable, and pluggable annotated bin. Okay, so we did that. I'm going to show you how we did it. I think there is some good feedback about once we're going to start to use with Spring 4.0 the extended annotation, the custom annotation, and the ability to configure and to reload the bins and have a custom configuration. There is here some good tools. One of the things that we did also on the reloadable bin, it's bins dependencies. Okay, so we annotated our bins saying these bins cannot be initialized until this other bin is initialized, and so created a dependency graph of bins inside our reloadable bin, and so being able to reload again and again with the dependency graph done correctly. It's running since 2006 flawlessly in a lot of environment. We have, so for example, the Spring server, okay, is receiving more than 2.5 million requests a day, something like that. And you can reload your bin in the middle of all this load dynamically, and we are really, really happy about it. So the main big interesting part, so it's Spring transaction, Spring transaction, Spring security for all the stuff, and Wicket. That's the two big components of the Artifactory and Artifactory environment that are plugged together and provide the web application. So go back. So no, this is not what I wanted. I'm going to go like that. Okay. So the main next listener, of course, after the home is the context and the Spring context. Okay. So this one is the one, like I said, that is doing, I don't know if you see the code from the back, the Artifactory init, which is this initialization threads, which is going to load all the threads and load all the Spring context asynchronously so that the web app will start immediately, and then we will have the context and the application context loaded asynchronously. So we create a context ID, which is based on the HTTP utils that we have. It's the JVM ID to make sure that, and depending also of the WAR ID. And so we just reconfigure here the here Artifactory. It's a full reconfiguration of the Artifactory home and Artifactory context. Okay, so context Unix name and Spring context path. I'm going to go into the configuration and the dynamic configuration, how we know what is the list of context. And here, of course, because we are a pure architecture based, so I have to go out of the view. I'm going to show you exit presentation mode. We are all okay. So, like, cannot make it bigger. Like I said before, the open source is a piece of code that we expose to the world. So there is inside our directory tree structure, of course, an open directory which contains all the open source. Okay, and this part of the open tree is fully buildable, testable, and runnable. Okay, and so we have the open architecture with the backend, the web, and so I used to have everything running already. The base environment with the API, and I don't know if you know this nice feature of IntelliJ, which I cannot, where I can see all the, I'm stuck. Navigate, view, code, analyze. You have an idea how I can show diagram of a module? It's yeah, no, it's down there. I cannot see it. Settings. Okay, because of the resolution here, I don't know how to show you the diagrams. So, how many of you use IntelliJ?
Make it smaller and the pop-up will show.
Hmm?
If you make your window smaller, it might show.
Which window? This one?
Your editor window, the big window.
This one?
IntelliJ window, yeah. If you shrink the size, you can drag it, right?
Yeah, no, there is normally show diagram here in the bottom. And it's a really nice diagram. No. Okay. Okay, I'm going to show you the one I saved. I should have saved all of them. Okay, that's the only one I have. Maybe if I do Control E. Here it is. Cool. Okay. Okay. So, one of the main thing about okay, I don't know if you can see. The main thing about the architecture is that we have a base API, which the web layer is using, okay? And this base API is basically completely separating what the core is doing and what the web is doing. Okay, so we have this ability. If you test your API and if our test our API layer, we are good. Okay, so this enable us basically to change after the different from the config environment whatever is available and whatever bin is provided by the configuration. So it's just string. Okay, it doesn't depend directly on which add-on and which implementation class is running. Inside the Artifactory config, you will be able to have different features and different behaviors based on the configuration. And the web layer just doesn't see the difference. It's all the same API and all the same interfaces. Okay. So this is a really basic API config and copy. So here is the web layer. So it's even smaller. If you do like that, maybe it will be better. So for the web layer depends on the REST API or all the REST jersey like I saw before, the database, and of course the API and the Artifactory command, which is implemented by all the different layers that are implementing this API. Okay, so we use Spring 3.320. But we still didn't use all the latest version of 3.2.0 for one big reason is because of this reloadable bin. Okay, reloadable bin. Okay, so what we did is that we created an interface, an annotation, reloadable, which is our own custom extended annotation, which allow us to declare what is the actual class that will implement this interface. So this is an annotation we put on our interfaces, and a list of other reloadable bin, a list of other bins that should be initted before this one. Okay. So if I go into all the different usage of the reloadable bin, here, for every single interfaces and API environment, I have a lot of the different reloadable bin that are used. Okay, so I'm going to take the configuration, this one, for example, which is here. Okay, I'm going to go here. So this is our implementation. We declare that it's reloadable. We said it's reloadable to implement the internal central config service class. Okay, so it's placing, and this is the key for after the auto-wired and auto-config of Spring, it's reading the internal central config class. This is the interface that Spring knows to do the mapping of what this implementation is providing. And we say that it's, this configuration can be initialized only after the database will be initialized, and the configuration change interceptor, of course, was initialized. Okay? So we create a graph based on those nice annotation of all the reloadable bin. And from this graph, when the Spring context is initialized, we know which bins to initialize first. And if something goes wrong, we failed immediately and fail early instead of trying to create all kind of things. The other thing is that for every reloadable bin, we have, so I'm going to go up in the chain, we have a reloadable interface. It's actually not mandatory for our environment. No, it's not this one. Okay, it's descriptor aware. We have a reloadable interface. This one, you see, it's not mandatory, and I choose the one that doesn't implement it. So there is also the reloadable interface, a reloadable bin here, okay, which allow us to manage version conversion. I'm going to talk about it, how we manage to automatically move from version to version of our system. An initialization block and a reloadable block. So the main thing here about the reloadable block is that it's taking what was the configuration before, the old configuration, and it's telling here, I want you to go to the new configuration, and this was the old configuration. And every one of our bins here can really do a really seamless and, how do you say it, without breaking any requests that are currently running, okay? So just killing some bins or killing some process in the middle, and creating a new bin with a new environment when you are doing the reload. Let's take, so there is the LDAP. We can reconfigure the LDAP, reconfigure our build services, our cache expiry system, our database services, our Groovy runner, all kind of interceptor, license services, the Maven metadata indexer, which one I'm going to take? Metadata definition, replication services. I'm going to take the replication services here. So the replication services inside Artifactory, it's the services that are looking at all the repository that were configured to be replicated with networks. Okay, so it's creating actual HTTP connection with remote Artifactory servers back and forth. So it's push and pull replication. And there can be a lot of push and pull replication currently running when you are changing the configuration of this bin, okay? And we don't want those replication to just fail randomly and crash because they changed their configuration during the processes, okay? So what we do is that we recreate and we apply the new configuration to the different queue. We create new replication handler here, and basically what we do is that we unschedule what used to be before, and we reschedule the new one, and we keep the old queue. We remove all the inactive queue, and we create the new or update the new queue. Okay, so we basically everything here. It's, I mean, now that you understand that I'm kind of cheating. Because what I just said is that it's reloadable bin. It's not really. It's always the same bin that knows how to reconfigure themselves. Okay? So it's like doing the after context initialized and being able to do it again and again with a new configuration. Okay? So basically, it's a pool, an executor service pool, and a queue, which will be reconfigured, and the next one that are coming in, and the next time that it's coming in, it's going to be with the new configuration. Okay? And I mean, we do it for every single system here inside Artifactory, and it's extremely stable, and we managed to basically reload this configuration and have the configuration reloaded without exploding the memory. We used to recreate a new environment context and try to relink, and that was exploding the memory, and the memory leak were quite annoying. Here, each bin, basically, and each module, you can monitor the memory usage, and you can monitor what actually is leaking from configuration to configuration, bin by bin. Okay, so it's a lot easier to test, a lot easier to monitor, and a lot easier to clean up than when you have a full graph of bins that are all depending upon one another, and you try to recreate a new one and make the replacement one by one. Okay, that works really, really, really good. Of course, here, so the pool is reinitialized here, and we are trying to make sure. So we have other also reloadable that are trying to stop what's going on, and so we have ability to stop. So for example, the one that we can stop is indexing. There is all kind of different kind of indexing if you are changing. So we are saying, okay, don't continue your indexing. We are changing the configuration of the indexing that you are doing, and redo a new one based on the new configuration. So this is the new kind of reloadable bin. We didn't look yet on how we could do that with all the new feature of the Groovy of the Spring Stack and the Spring environment. But I'm looking forward to try to use a lot more the dynamic custom bin configuration and environment on the Spring Stack. Okay. Okay, so like I said before, one of the strong, interesting part. So just for the story, when we started the cloud, like I said, we took the open source product. We were really happy. There was a lot of users and customers and company using the open source product. And we said, okay, we're going to make a cloud version out of it. Okay, so let's take the same application and let's deploy it on Tomcat, and let's deploy, because, I mean, on Amazon, we are running on Amazon. Amazon RAM memory costs a lot. Okay, if we are creating one Tomcat server for each one of our customers, we have more than 300 customers on our cloud platform today. We will just pay Amazon for all the memory that we are using, so that was way, way much more than what we could do. So we said, okay, we're going to put multiple WAR on the same Tomcat, multi-tenant. Okay, this is why it looks like that. This is the multi-tenant that we do for Artifactory Online. We have one Tomcat, and we deploy multiple WAR. We were really happy. We cleaned up the static code and all this kind of stuff, and we have the WAR file, which is today in Artifactory, it's still a 35 meg WAR file with all the libs and all the dependencies. And so we deploy it once, we deploy it twice, it works great, 3 times, 4 times, boom, permgen. I don't know if you had the experience, but every time, basically, it's recreating a full class loader, and it's reloading all the classes inside the permgen for every WAR that we were deploying. Okay, so it was end of 2009. We wanted to launch the cloud version by the end of the year. And so we were 2 months before launch, and we didn't know what to do. We could not deploy more than 5 WAR on the same Tomcat. Okay, that was not suitable for what we wanted to do. So we said, okay, let's go back to the beginning. And what we did is to try to put as much as possible from the jar of the lib of the application inside the Tomcat shared lib class loader. Okay? And of course, as soon as we did that, a lot more static and a lot more static member appears and started to corrupt the code and corrupt our environment. And so we worked quite some times. Today, basically, when you go online to JFrog.com and you ask for a free trial of Artifactory Online, the only thing we generate is a web.xml. Okay, it's a WAR file with one web.xml. All classes, all library, all jar is inside the shared class loader of Tomcat. Okay. And so we can deploy the 80, 90 WAR file on the same Tomcat. Okay, and it works great. Of course, it takes quite some, process and energy, and to make sure that everything is okay to do like that. And one of the main things we had to remove is, of course, I don't know how many are doing that, but the singleton application class loader, application context of Spring. Okay, one of the main things you do when you create your application context of Spring, you are inside your JVM, you create your application, you create a singleton, and everybody can access the application context. There is nothing easier than that. Of course, this is not working here. We needed to have an application context, which is based on the thread context and on the WAR context and the web context. Okay? So this is why it's linked to the web XML, and this is why it's a listener, and it's strongly linked to the web environment. We have jobs also. We had to rewrite the executor, the thread pooling, and all this kind of stuff. But today we are really, really happy. There is no static code. Everything is based on the thread local store and the executor and pool, which we rewrote. Yeah.
What would be the advantage of using a single Tomcat instance and multiple instances of the WAR?
Memory.
Than having multiple Tomcat instances on the same server?
Memory. It's more than memory. When we run an upgrade, when we upgrade the version, okay, we can upgrade the 80 WAR server. Okay, it takes us less than 10, 15 minutes to upgrade the Tomcat with the new version. Okay, if we had all the Tomcat. So in terms of management also, DevOps, pure DevOps management of the Tomcat. The other thing which today is is that our Tomcat are hot. I don't know how you say it, but when we, in the DevOps, we use Chef to deploy the new Tomcat to the Amazon cloud. And so we create the Tomcat on an Amazon instance, and there is no WAR file. But all the classes are already there. The Tomcat is hot, is ready to receive the WAR file. So the deployment time of a WAR file in our cloud environment is 4 seconds. Okay, so we put the WAR file with the web XML. In 4 seconds, the guy is up and running. Okay, so in terms of load distribution and load management and the ability to distribute the web and the WAR file into the different instances, it's huge, huge advantages. To bring up a Tomcat with a WAR file and reload all the classes and things like that, if you get below 5 minutes, you're happy. You know what I mean? 5 minutes is a really good time. So, I mean, that's really an order of magnitude in terms of, but yeah, at the end of the day, every Tomcat that you're gonna run, it's the Tomcat memory plus the Tomcat WAR and all these kind of things. It's 40, 50 meg of RAM, okay? Here, so we use one of the top of the line Amazon instances with 64 gig of RAM. And on this 64 gig of RAM, we can run 4 Tomcat, and each Tomcat has 60 WAR file. And everything runs, so it's really, really running smoothly, and so it's cool. So, I mean, you know what I mean? It's, I know it's reducing our cost, but no, everybody is, it's actually, no, everybody's, it's a lot more performance and a lot more stable and happy. To tell you, I mean, it didn't happen in a day, okay, all this improvement and all this, this management and environment. But we are serving a lot of IV users and a lot of really, really heavy users that are really sensitive to every percentage of error on our Artifactory platform. And today we are below 0.0. I looked in New Relic. We use New Relic to monitor. We are below 0.05% of error rate. And a lot of them are actually bad requests from customers and stuff like that. So
when a new customer wants to get Artifactory, right? So does he have to go through an admin system that
yeah, exactly. Then deploys the WAR? Yeah. And the creation of the WAR, like I said, it's customized web XML for him, for his environment, his database. He has his own storage, his own file store, his own file system and everything. But it's just a web XML that is created and deployed to whatever Tomcat can receive the load. And it's load balanced and distributed. So it proved really, really. Like I said, what's nice is that it's the same code base that is doing all this nice looking trick than the one you are getting when you are downloading the zip or getting the Pro version or the Pro RPM on your site. it's even better than that, is that in our platform, we are deploying the Tomcat with everything we do in our RPM. So when you are getting the RPM version of Artifactory OSS or Artifactory Pro, inside the RPM, there is also all the OS tuning and all the Tomcat tuning that we did for the Tomcat here that is going back to the open source guy. So really, we are not trying to hide anything, and we really provide back all our experience from the cloud back to our users and customers. Okay. So the other interesting part is the pluggability. Basically here it's, for us, the ability to have the same interfaces, okay, the exact same interfaces for the web, for the UI, for all the different pieces of our infrastructure, which are implemented differently depending on the licenses that you get, if it's OSS, Pro, Artifactory Online, or HA. And so to be able to reload those different pluggable environments dynamically. So here, I'm going to show you how we do that in the Spring environment. It was kind of easy, actually. Okay, so I'm going to go back.
I just have a couple more
Yeah,
questions.
sure, should.
Now, we can deploy that all the code in the shared library, provided that the UI is fixed for all the customers, right? But what if customers wanted to change the UI or customize the UI as per their requirement? Then within the one file, we'll have to have some other files, either the template files that the customer wants to use, or I don't know.
Yeah, so Artifactory has a customizable UI. I don't know if you saw, there is a different logo, different colors, and there is the Pro version and the OSS version is not the same UI. So the UI is customizable, but basically it's the application doing the customization depending of what it's loading. So there is different, and like I said, we use Wicket. So in Wicket, it's a little bit like Swing for web. Okay, so you have an API that defines a panel, and this panel has a different field or whatever, and they can be implemented differently. The panel may be not implemented at all, actually, for the OSS, and implemented fully for the professional version. So in Artifactory, the UI customization is part of the application itself. So it's the same libraries, but every web XML has its own configuration space, its own file store space, its own databases. Okay, so all kind of UI configuration which goes and create files like logos and PNG and stuff, it goes to its own space, and the database configuration goes to the database. So it's well isolated, and everybody can get a different look and feel and a different environment. There is no issue.
The question I have is, like, when you go through an upgrade cycle, right? So you have 60 customers which are sharing a single instance of the application. How do you go about doing that? So you have multiple instances of that Tomcat running, and
No, it's the same Tomcat, multiple WAR files, so they have different names. It's the name of the customer. So they have a different web context, okay? And by the web context, each web context is associated with a new Spring context. And the Spring context is the same classes, okay? This is the main point, is that the Perm Jane and the Java classes are the same, but the Spring context is completely different. Okay, it's a different configuration of the Spring context. It's a different configuration of the reload. There is actually different classes also, because there is also the Groovy, and I'm going to show the Groovy users plugin. So they have also different classes for plugins. But the basic the basic Tomcat contain all the library in the shared lib of the Tomcat. And so it's different web context with different configuration and different inloaded memory, and everybody is completely isolated in terms of each one of them is a different DB service, which is connected to the database, a different database, and each one is using a different Artifactory home, which is a different configuration and a different file store. So it's well fully isolated. it's a little bit like, it's not Google Apps. Google Apps is one big application with the isolation of data. It's more like Amazon Store, you know, when you create your own Amazon Store kind of things. CloudBees is working like that also. It's when you have your own virtual hosts and your own environment, it's really separated private environment for each one of you. Okay. So yeah, what I wanted to show is the pluggability and how we do that. And so basically where we do that is inside the config and the config listener. The Spring context, so I lost it. Spring config path. Okay. So what we created here is basically an immutable list and a dynamic a list of paths that should be loaded for all the beans and all the different environments that should be loaded. Okay, and so we provide to Spring and to the Spring application context this list of paths, and we know which of the add-ons and what are the different implementation of the add-on we need to provide to Spring. Okay, so the best place to actually see this is inside the application context XML. Okay, in the application context XML, it's quite small. Most of it is due with the annotation, the reloadable annotation here, which we define and we tell Spring, this is the way we declared Spring beans inside our Spring context. You look at all the reloadable. There is the test, I'm going to talk about it after. And we have just here the transaction interceptor, and that's it. Okay? So all the work and all the configuration work is how this application context is loaded using here this Spring config path, which will provide the list of XML and the list of beans that needs to be loaded inside the application context of Spring. So I'm going to take one of these, addons.xml, which one I have here. Enable mock, tests, yum config. How come I have only one? Addons.properties. It's add-on without the S. Okay. So this is all the add-ons. This is just for us. This is not for Spring, where we define. So here is each one of those professional add-ons. The name of the add-on, the version, the display name, and some kind of order inside the different add-on. Can you go back to? I'm going to go into. Okay. One. How many of you are doing this converter manager? So the converter manager is basically automatic conversion of database, configuration files, any kind of system on your product. Whenever you have a new version of Artifactory, you are taking it, you are dropping the new war on your Tomcat, and immediately Artifactory will look at what is the original version of your database and of your file system. We'll know what is the current version of this code, okay, and will convert automatically all the code base, all the database, and all the file on the file system, okay? So it's an automatic process. It runs, of course, on our cloud environment quite often, and it runs on all our customer environment every time there is a new version, okay? So we created the platform to do this automatic conversion from version to version. I like to have a poll here about who's using any kind of framework or tools to actually do that, and who is doing it. Anyone is doing this kind of stuff? No? Okay. Anyone like to do that? Or you just say, okay, I pay, you have to pay me for services to actually do the conversion? So So basically, we are sticking to what we have. We are really proud of what we have. And so we created the version converter matrix. And for each component of our system, every different component of our system is whenever they are changing either the database schema or the file system, okay, the MIME type. For example, we just added the gem support last month. So for the gem support, we needed to change the MIME type that we are managing. Now we are managing the Ruby gems and the Ruby gems files, okay? So to manage those new files and to be able to let Artifactory what kind of files they are and all these kind of things, we needed to do a MIME type converter. And so we created a converter that's reading the MIME type declaration that you used to have and adding here inside the Ruby gems and the new Ruby gems support. Show me the code. Go for it. So inside the Ruby gems support, Ruby gem dependency, test, Ruby helper. Oh, it's only Ruby helper. Okay, maybe I can go from here. Name, version, so re-indexing on the tuple. I need alt1. Here it is. Here it is. Okay, so this is the add-on for gems. This is the index and the metadata. And so the gems add-on implementation, I'm going to go first for the distribution information. Okay. Okay, so we're going to go into all the detail here of the gem. Some of you know Ruby or using Ruby or not? Not that much good for you. So the main thing here about here this new, I'm going to make it bigger. So this is a typical add-on inside Artifactory. It's quite a big one, okay, for all the gem supports. And when you go to the open source version, you see only the interface of the gem. You can see that gems can be provided, but there is no real implementation. When you go to the professional version, there will be all those new implementation of the gem support and the gem YAML and the XML support. And the next one is the one that I wanted to show you. Hopla, he's here. So inside the base base update. Here it is. Okay. I'm going to start with Artifactory version. Okay. So anyone like enums? I really like enums. I started, by the way, a project which was extended enums. I don't know if you, the ability to extend enum, to have enum extend enum. So that was one of the kitchen sink project when Oracle Sun opened the Java-C compiler. So I really like enum, and so we used enumeration to basically classify here, like I said, this version matrix, okay? So every time we have a new version here, we set and we declared the release number and the version matrix for all the different versions of Artifactory, okay? So that's the basic flow of Artifactory version here. And for each different environment, so here it's for the version of 103. Project production. Here it is. MIME type version. Like I said before, the MIME type change. So here is one of the system, which is the MIME type system of Artifactory. the MIME type system of Artifactory. Every time there is a new MIME type that we need to support and a new kind of file that we need to support, we create a new version of the MIME type version, and we link it to the version inside Artifactory. And so automatically, when Artifactory starts, it looks at all these different subconfig, those different converter, and this different kind of converter that can be, between the original version and the final version, and it's running converter by converter. Here, it's the gem MIME type converter, and the gem MIME type converter here, what it's doing is basically adding the Ruby gem support and saying that there is a special kind of CSS for the Ruby gems, so to present and to display the Ruby gems, and also that the Marshall for the RS and all kind of small code here. It's Java code, I'm sorry. We write mainly Groovy today, but here the Artifactory is still in Java. And so here, basically, every different developer and every different modules can plug themselves to the converter manager and tell basically the system from this new version, I need to go to the next one. Okay. Yeah, I think so. Okay, go back. Okay, the add-on manager, I showed you a little bit about the properties. So every add-ons just declare the properties. And inside the config manager, we are reading all the add-ons XML and the add-on property that are available. And depending on your licensing, we can load the different bins and the different implementation. It's, like I said, it's layer on top of layer. Extending the UI, so I'm going to show you. Now, show me. So the, hopla. Control-E. Support config section. Here it is. So for the UI, here what we are using is Wicket. So this is a web market container of Wicket. I don't know if you know Wicket, but basically in Wicket, it's a little bit like Spring for the web. Okay, so you define classes with all kind of elements, title behavior, style check, schema bubble, re-index link. And so here, this web markup container of the gem config section, okay, it's used here in the, where I am? Yeah, here it is. Build package config section. Web markup container. Okay. Where is the interface? Gems add-on here. Okay. So this gems add-on implementation, you can see it doesn't have the annotation reloadable. It doesn't have any annotation about Spring. So it's not loaded automatically by the class path parser and by Spring. It's loaded only by the add-on XML and by the config implementation. If it's not loaded, there is actually another implementation here. If I do Control-Alt-B, there is the gems add-on and there is the basic Wicket add-on. Okay? And inside the Wicket add-on here, there is a different here implementation, which basically is going to provide the default implementation of this UI, okay, for the open source version. Okay, so in the open source, you're going to see the same UI with different features, okay, and it's going to provide basically different kind of links and different kind of panel for the open source version or for the professional version. In the professional version, it's going to be a new kind of web market container with all the features and all the environments. Okay, so it's dynamically changing and injecting the different panel depending of which version you are in. Go back. Okay, REST API. So here I mean we are using Jersey. It's quite straightforward. You just annotate all your Jersey class. Of course, there is some REST API that are pure for the professional version. What we did here, we could have put some of the Jersey classes and the Jersey path implementation only in the add-on and the add-on jars of the professional version, which will have made Jersey extendable. The main issue we had is WebSphere. I don't know if anyone ever suffered from WebSphere, but as a as a consultant, I suffered a lot from WebSphere. Basically, in WebSphere, is not capable of Jersey is not capable of doing his annotation parsing from multiple jars. Okay, to create a class path of multiple jar and doing the multiple parsing, it's really, really hard in the WebSphere class path and class loader. So what we did for Jersey is that we created one single jar with all the Jersey resources, and we reused the system that you saw before, which is the N version of control, and we have different implementation if you are open source or if you are a professional version about what those Jersey call behave and how those Jersey call behave, depending of the version you are running on. So that's just for the list story. I don't want to show, no. No, I don't want to show it. So, like I said at the beginning, what is the main layers? There is more layers. So the main point about this architecture inside Artifactory is that now I think we are even creating way too much, but we are really, really capable of doing this extension of extensions of extensions and having a really, really nice pluggable environment where we can put more and more pluggable features. I don't know if any of you looked at the GitHub architecture, for example, how GitHub is doing all these kind of things. They are really, really keen on a feature switch, and so they can turn on and off the different features and make sure that some of the features are good for the GitHub platform or not. Okay, this is the kind of things that we are doing today inside the Artifactory and Artifactory Online and the JFrog platform. We can actually plug more and more features and different implementation depending of which layer and which environment, and go back and forth between those layers. And one of the really, really nice feature, it's more than a year and a half ago now, almost 2 years, that we added also is the users plugin. So one of the main things we can do now inside Artifactory is to add any kind of groovy code and hook any kind of groovy code at any place, I mean, at some special exit point inside the Artifactory code base. We have a talk tomorrow about how we did that in the Groovy, so it's Baro that's going to talk about it. How we manage basically to inject Groovy code and Groovy code base dynamically without reloading anything, the same kind of reloadable environment, and make Artifactory behave in a different ways when there is a new artifact coming in, when there is a new build coming in, when a new authentication manager, all kind of cool new stuff inside this environment. So I'm not going to show the code because we're going to show it tomorrow. What I want to talk about in the next 5 minutes that I have is about how did we do the tests. Frankly, I'm talking more and more. I really believe that the only thing that is really, really important in an application is your tests. If I had to decide between losing all my production code or all my test code, I think I will choose to lose all my production code. Today, creating, once you have really good tests that are really covering the list of functionality that you are offering and all your environment, you are really defining your software by your test. What we did with Artifactory 3.0 is quite impressive. We really managed to, with high level of confidence, completely change the heart code of the backend of Artifactory and have a new version of the storage engine of the Artifactory system, and being quite confident that all the backward compatibility of all the API that we were offering to our customer and users will not change, okay, because of the test and the configuration. So here the main issue in our environment for the test is that we start to need to test at every single layer. We need to test at the unit testing, so this is standard unit testing of your module and your packages. But we need to be able to test the open source version, to test the professional version, to test the cloud version, and to test every kind of this version with different class path and different loading and configuration, okay? So basically, so unit test, they are all green until I wrote my code. I'm not going to show the unit test. I'm going to show first the first integration test. There is also another kind of test which are really, really tricky to do. It's upgrade and upgrade of the schema test. Okay, so once you get into this kind of issue, you will see. So, like I showed before, here in this application context, there is the component scan that we declared for Spring, and there is a regular expression where we say, please don't scan the test and the DB integration test. Okay, and so here, basically, inside test and DB integration test, for all our tests, we use the pure Java config. Okay, for all our integration tests and for Spring, it's pure Java config. There is no more XML loading for most of our low-level integration tests. Why we are doing that? Because each one of those modules that have this Java config and Spring Java config, we are defining the class path and the dependency exactly like it should with the good class path. And so we know that what we are testing, and we know that we are not testing professional features and things like that. The other thing that we are doing about storage DBI test is that, as I said before, once you load the DB service is converting automatically the database. Okay? So if you want to test how the database is converted, you're kind of stuck. You load the DB service, it's already converted. So we have another DB integration test, which is so what I wanted to do is to look at Git and look at Git of how the DDL and how the database was in previous version, and load the previous version and do the automatic conversion based on Git. It proved to be quite difficult, so finally what we do is that every time we do a new version, we just copy the DDL and we just automatically test all the conversion from one version to another in all the different environment and tests. So we have integration test here for the storage, and we have full integration tests, go back, for so the higher level of test, full integration test for the professional version, integration test for the replication, so we can run multiple instances, and they are all replicating one to another, running, and here we are using the AOL feature, the ability to run multiple war on the same Tomcat, and so we can run multiple tests. And we have implemented also a mock server for testing a remote HTTP server and environment. So I think I talked way too much that I thought. Thank you.